Hello class 10. After a long time, I'm going to make a video for you all. And in this video, of course, we are going to talk about earthing. What earthing means in an electrical circuit, we are going to talk about that. Now, when we speak of earthing in an electrical circuit, we basically mean two things. One is called local earthing and the other is called earthing of an electrical appliance. Obviously, we are talking about electricity, so it has to be an electrical appliance. Alright? But do get one thing very clearly, both of these two connections, it's like these two are different connections, local earthing and earthing of an electrical appliance, but both of these are connected. Literally, they are connected. Okay, although I am showing it to be two different topics, and we of course understand earthing in two different ways, but these two are literally connected. We'll see how. But first, let us talk about something called local earthing. Now, what happens in local earthing is, the most important thing is we have a copper rod of a certain length, of course, and it could also be a thick copper wire. Now what we do is, we say this is the surface of the ground, so I've written ground over here, so this is the surface of the ground. We dig the ground for about 2-3 meters. So 2-3 meters deep, we dig a hole in the ground. And what we do is, we take this copper rod or a thick copper wire like I told. So here is copper rod, or it has to be a thick copper rod. Now this copper rod is covered by an insulating pipe, hollow pipe of course. When I say pipe, it has to be hollow. So this copper rod is insulated by a copper wire, is covered. So you insert that copper rod in that hollow insulating pipe, and the whole arrangement, that is the copper rod or the thick copper wire and the insulating pipe, hollow pipe of course, is inserted in the 2-3 meters deep hole that you've dug in the ground. Alright, so this arrangement is inside the ground now. This is the surface of the ground. You've inserted this copper rod and the insulating pipe in the ground. Now, this is the lower end of the copper rod or the thick copper wire. This is the lower end. And to the lower end of the copper rod, what we have is we have welded, or we weld a thick copper plate of dimensions of about 50 centimeters into 50 centimeters. So the length is about 50 centimeters, breadth is about 50 centimeters. So a copper plate is welded to the lower end of the thick copper rod or the thick copper wire. And what happens is, around or surrounding this copper plate, we have a mixture of salt and charcoal. Charcoal is, graphite basically. So it is a conductor of electricity, remember. It is the non-metal which conducts electricity. So we have a mixture of charcoal and salt. Now the upper end of the pipe is above the ground surface, just above the ground surface, so to say. So time, at certain intervals of time, what you can do is, you can pour water through the upper end of the pipe. The water that you pour through the upper end of the pipe, or from above the ground, so to say, reaches the mixture of salt and charcoal, and of course the plate here. Now what that does is, it makes the connection with the ground of the copper plate. It increases, so to say, the conductivity of the copper plate with the ground. So when you pour water, the surrounding of the copper plate gets moist or damp, so to say, and that increases the conductivity between the copper plate and the ground. So that is why we time and time again, we pour water through the upper end of the pipe. So basically this earth connection is done near the house. Near every house there is earth connection done, but like I've told you in one of the videos, some of the houses, they do not have the earth connection. Earthing, so to say, is not done. Alright? Now when we say earthing is not done, we mean local earthing in the house is not done. So that is also possible. But earthing is done for the safety. Remember, it's done for the safety purpose. We will see how safety, it helps in the safety of the house and of course of the persons involved. So this is about earthing, remember, this is what is called local earthing, and this earth wire along with the live and neutral wire, we've discussed that the live and neutral wire comes from the power station, remember. So if the local earthing is done this way, then live, neutral and the earth wire denoted by E, okay, they go to the kilowatt hour meter in the house, and from the kilowatt hour meter it's distributed, it goes to different rooms of the house. So this is what is called local earthing, remember. Okay, anything left that I need to tell you? So you might be asked, what is the use of the mixture of charcoal and salt? Alright, so the mixture of charcoal and salt, and time again you pour water here, that is done to increase the conductivity between the ground and the copper plate, between the earth and the copper plate, so to say. Let us now talk about safety due to local earthing. How local earthing, so to say, helps in the safety of the house and safety of the persons in the house, of course. So what happens is, if you will have an electrical circuit, a lot of electrical circuits in the house, of course. If in any of the electrical circuits, say due to some reason, due to some factor, a high amount of current flows through the electrical circuit, then if local earthing is done in the house, what happens is, a high amount of current is flowing through the circuit. The high amount of current flowing in the circuit may be due to short circuiting. You must have heard, a particular house or a shop caught fire due to short circuiting. The term is short circuiting or short circuit, so to say. So what is the meaning of short circuit? Short circuit means a passage of high amount of current through a particular circuit. Now, a high amount of current due to some factor, of course. If a high amount of current flows in a circuit, that high amount of current generates a lot of heat. I have spoken about Joule's law of heating. So high amount of current flowing produces a lot of heat, and that heat, if local earthing is not done, can cause fire in the house. So a house caught fire due to short circuiting means that high amount of current flows in the circuit and a lot of heat is generated, because of which the wires catches fire and thereby the house catches fire. But if local earthing is done, then the high amount of current flowing in the circuit passes through the earth wire, and reaches the ground. Now the ground or the earth is a huge or infinite conductor, so to say. So no matter how high value of current flows through the wire, earth wire in this case, the ground is ready to accept any amount of current, which basically is flow of charge. So it is ready to accept any amount of current or any amount of charge coming towards it. Right? So if local earthing is done, then the high amount of current that is flowing in the circuit, it flows through the earth wire. We will see how it is connected to the earth wire. So it flows through the earth wire and reaches the ground or the earth, which is an infinite conductor in itself. And thereby, since the earth is conducting the high amount of current, so therefore it saves the house from getting damaged, because all of the high value of current eventually flows to the earth. But if local earthing is not done, then it could be dangerous. Alright, if local earthing is not done, then like I have already told you, high passage of current generates large amount of heat and thereby the wires catches fire, and also thereby the house catches fire. So this is how, remember, local earthing helps in the safety of the house. Let us now talk about earthing of an electrical appliance. Now, say this is your electrical appliance that basically earthing of an electrical appliance is done for those electrical appliances which we physically touch, like an electric iron, or say for example your geyser or your refrigerator. Now, so say this is the electric iron. Now this electric iron will have a metallic case from the inside, of course. Now these days we have plastic covering also, but inside the plastic covering you have your metallic case. So this is your live wire, of course. the live wire, to the live wire we have the fuse and the switch connected, and this is a neutral wire. And this is your earth wire. This earth wire, mind you, is connected to your local earthing. Okay, so that is why I told you that, earthing of an electrical appliance and local earthing, they are connected, because this connection here is for earthing of the appliance, and the earth wire is then after it goes and gets connected to this wire is connected to the local earthing. Now what happens is, you turn on the switch, of course current is going to flow through the live wire. Okay, these are insulations, these blurred lines that I have drawn over here. It depicts the insulation of the metallic case from the live and the neutral wire, remember. Okay, so the live and the neutral wire, of course they are to be insulated from the metallic case, because if they are not insulated, you touch the metallic case of the electrical device, then of course you are going to get a shock. So the live and the neutral wire, they have to be insulated. And this is the resistor towards which the current flows through the live wire, and this gets heated. The resistor obviously is going to oppose the flow of current, and higher the value of resistance, more the heat it generates. Okay, so this resistor gets heated up in an electrical device or also in a geyser. Okay, and because of which you get the electric iron or the geyser gets heated. And from the resistor, the current flows back to the source through the neutral wire, remember. Now, what is the use of the local earthing? Let us say, to understand that, let us first disconnect the earthing wire. Say we don't have the earth connection. There is no earthing done in the electrical appliance. Then this is the electric iron, say we are talking about. Then like I told you, if somehow this insulation breaks, say for example, with time of course the insulation wears out and the insulation breaks, then what happens is your live wire comes in contact with your metallic case. So when it comes in contact with the case, metallic case, what happens is you touch the metallic case, you physically handle it of course, so you touch it, then what happens is you get an electric shock. Alright? But if earthing of the electrical appliance is done, and of course if you have done local earthing, we are considering the case that we've done the local earthing, and the electrical appliance also has its earthing connection done. So what happens is, earthing in an electrical appliance is done in such a way that the earth wire is connected to the metallic case of all itself, okay, through some terminal. This is the terminal over here. Using some terminal, what happens is the earth wire is directly connected to the metallic case. So live wire and neutral wire, they are insulated from the metallic case, whereas the earth wire is directly connected to the metallic case. Now, due to some reason, of course, the insulation breaks after some time. With time, the insulation wears out and it breaks, such that the live wire comes in contact with the metallic case. Of course, the metallic case has current, so to say, flowing through it when the live wire gets connected to the metallic case itself. If the earthing is done, of the appliance is done, then what happens is, the current that is flowing in the metallic case itself, the metallic case itself being a conductor, the current then after flows through the earth wire. It goes towards the earth wire, because the earth wire is easily connected, is itself connected to the metallic case. So what happens is, a large amount of current flows through the earth wire. Now, why a large amount of current? Because both the earth wire and the metallic case, they are conductors. As so far the live wire was insulated from the metallic case, what happens was it was flowing through the resistor, and the resistor was opposing the flow of current. Okay, now when the live wire somehow comes in contact with the metallic case, a large amount of current starts flowing, because the metallic case being a conductor, it offers no resistance. So a high value of current starts flowing. Now that high value of current, since earthing is done, flows through the earth wire, and it easily reaches the ground, remember, because local earthing is done, because this wire is connected to the local earthing, remember. So this high value of current flowing to the earth, to the local earthing, so to say, in turn breaks the fuse. Okay, because initially the resistor here inside the metallic case was opposing the flow of current, so a certain limited value of current was flowing. But since the current starts flowing through the earth wire into the local earthing and thereby to the earth, high value of current starts flowing. Because of the high value of current flowing, the fuse wire gets disconnected. So to say, the fuse wire melts and thereby breaks the circuit. Now, since the circuit is broken, now you touch the metallic case, you do not get an electric shock, of course. So you are saved from getting an electric shock. So remember, this is how local earthing and the earthing of an electrical appliance helps, and and prevents the damage of the appliance itself, and also prevents us from getting a shock. So this is about local earthing and earthing of an electrical appliance. Thank you.